All right, this is 12.7 Effects of Outliers for 6th grade. So first off, let's define what is an outlier. An outlier is a value that is much less or much greater than the other values in a data set. Remember something like this is our data set, where we just have a bunch of numbers and we have to find our measure of center, whether it be mean, median, and mode, which is what we talked about on Friday. The table gives the number of days that 24 members of the Herman Norcross volleyball team were absent from the school last year. And the question we have to figure out is, what is the outlier? There's a little baby question mark in there. Make sure that you are writing down every single thing that is on the screen, including the picture of our data set. Okay, you're going to need to know that if you're looking back to try and remember what is an outlier, how do I use it. You're going to need to know what numbers you worked with. So make sure you do take the time to write out your data set and do everything that I'm doing, okay? So the question is, what is the outlier? So to find the outlier, we are going to use a dot plot to find our outlier, okay? That's a 1, a dot plot to find the outlier. Okay, so again, we have to draw our line here. Okay, we have, looks like the smallest number I have is a 3. And then I have to go all the way up to 16. So let's go by 1s, 4, 5, 6, 7, 8, 9. Okay, so I just jumped up to 17 there. Give 1 extra for good measure. Now let's go through and put in our dots where they belong. I'm going to go through. I'm going to pause the video for this. You can do this on your own. So just you pause the video while I'm doing it, and then you'll be able to catch up with me when you're all done. All right. All right, so here is what my dot plot looks like. Yours should be the same. You should have 2 dots above 3. 1, 2, 3, 4, 5 dots above 4. 7 dots above 5, 1, 2, 3, 4, 5 dots above 6, 3 dots above 7, 1 dot above 8, and 1 dot above 16. So now again, I'll read our definition of an outlier. Our outlier is a value that is much less or much greater than the other values in the set. Now I notice when I look at this set, I notice I have a lot of dots that are around here. Okay, that's where all my dots kind of congregate. And then I have to jump quite a few ways, and then I get to this lonely little dot way out here. So with the question, what is the outlier? The outlier is 16. 16 is our outlier because that is the one that is way farther away from our collection or our group of our data. Okay, all of our data is about right here, and then we have one that's way out. It's much more than the other values in our data set. Okay, so that's how we're going to find what a dot liar is, by drawing a dot plot. Now let's kind of see what effect that has on our mean, if there is an outlier. Does it change our average if we add a number that is way higher or way lower? That's what we're going to do on the next slide. All right, so this problem says, the high temperatures for the week in Herman in degrees Fahrenheit were 43, 43, 45, 42, 26, 43, and 45. Okay, the mean of the data. So using all of that data, our mean is 41. Okay, 41 degrees Fahrenheit. Identify the outlier and describe how the mean and the median are affected by it. Okay, so we have to do mean and median. So anyways, first we're going to draw a dot plot, our good friend the dot plot. This one can be kind of skinny because we don't have a whole lot of numbers here. I'm going to start with my biggest number, which is 45, then go down. Okay, so here's what my dot plot looks like, going from 26 because I saw that was my lowest, and then I went up to 45 because that was my highest. Okay, so now I have to fill in my I don't know why I have such a hard time saying that, my dot plot using the data set. Okay, so I have, starting with 45, looks like I have two 45s. So I'm going to put my two 45s there. I have 43 43s. Okay, so I'm going to put my 3 43s. Remember to make them neat so we can see that there are more 43s, right? Because if I scrunch all my 43s up and they're the same height as my 45, which only has 2, then we're going to have a problem just looking at it. Okay, so I've got my 45, 45, my 43, 43, 43. Looks like I have one 42, so let's put our dot above 42. And then lastly, I have one that is 26. I think it's pretty obvious what our outlier is, but this right here is where all of our data is, and then we make a big jump to get to this little guy out here. Okay, so what we need to do for that little guy, he's our outlier. So first it says that the mean of the data is 41 degrees Fahrenheit, including our outlier of 26. Okay, identify the outlier and describe how the mean, so we have to identify the outlier. So we're going to write outlier is 26. How is the mean affected? Okay, so now I'm going to find the average or the mean of just the numbers that are in the circle. I'm not going to use the outlier. So we're going to say mean without outlier is, so let's figure that out. We need to do 42 plus 43 plus 43 plus 43 plus 45 plus 45, all divided by 1, 2, 3, 4, 5, 6, because there are 6 numbers. Okay, if I add that all up, I will get 261 divided by 6. Okay, and if I divide that out, I am going to get, again, we'll do top, 261 divided by the bottom, 6. 6 goes into 20. Sorry, that's terrible. Let's try that again. 261, 26, or 6 goes into 26 4 times, minus 24. So I would get 2 left over. 6 goes into 21 3 times, so I'd subtract 18. And I would get 18, 19, 20, 21. I get 30. If I put up a decimal point, bring down a 0. Okay, so 6 goes into 35 times. So the mean without the outlier is 20. Oh, sorry, not 20. The mean without the outlier is 43.5, or 43 and 5/10, 43.5 degrees. Okay, so now we have to say what's the difference between the two. So the mean with the outlier, remember that was 41. Without the outlier, it goes up 2 and 5/10 degrees Fahrenheit. How I figured that out is I took my mean without my outlier, 43 and 5/10, and I subtracted my mean with the outlier, 41.0. So then I would get 5 minus 0 is 5, and 3 minus, bring down my decimal, 3 minus 1 is 2. Okay, so the difference is it went up 2 and 5/10 degrees Fahrenheit. Okay, so now the question asks, we got identified our outlier. We described how the mean is affected. Now we have to find out how the median is affected. So we have to go from smallest to biggest. So I would have, so the median is, and the median without outlier is, all right, so let's order them. I'd have 26, 42, 43, 43, 43, 26, 42, 43, 43, 43, 45, and 45. Okay, so with the outlier, our median would be cross off, cross off, cross off, cross off, cross off, cross off. Our median would be 43. Now let's figure out without this little guy down here, our outlier. So I'd cross off, cross off, cross off, cross off, 43 and 43. So I know the average of a 43 and a 43. If I add them up and divide by 2, I'm just going to get 43. Okay, so the difference of median with the outlier and without the outlier is 0. It is exactly the same if we have the outlier in there, if we do not have the outlier. The median is, but the mean went up 2 5/10 degrees Fahrenheit when we took out that low outlier. Okay, I just want you to do your best on this. All you're doing is comparing what if I have that outlier in and I find the average? What if I take that outlier out and I find the average? What's the difference between the two? And how can, well, you just have to tell me what is the difference. Not even how you can use that, just what is the difference. Okay, I want you to work on page 479 and page 480 in your math book. And then you have to do your work on your homework. I'm guessing this should take enough time. Mrs. Work has the answer keys, so you can go check with her to see how everything is going. Otherwise, I will see you tomorrow, and I hope you guys have a great day.